This week we talk about putting it all together and writing a forecast. I know all of you have heard a forecast written at some point, whether it's a bad one or a good one. And I'm sure you've noticed that some just don't always work out. We've been looking at a lot of stuff this semester, so we're putting it all together to write a forecast. If you're going to write a forecast, you need to know what's going on first. So let's look at the United States from a satellite perspective. So if I am looking at this, what do I see? Well, I see some clouds and actually almost like a circulation down in here somewhere. I see that there is a circulation up here in Canada. You can see clouds rotating around. I see clouds coming off the Great Lakes here and here on Lake Erie. See a whole deck of clouds coming down in this area. And what looks like a lot of cumulus clouds down in here across northern Florida and off the coast. So just generally looking at this, I would guess that looking at the line of this area of clouds and stuff, there's probably be some kind of front in here somewhere. And may even be another front coming down up in here to the north. But this is just visible. So let's take a look at something a little different. How about we look at water vapor in the mid-level? I love water vapor because it gives you an idea of where moisture is coming from, what's happening with it. So, band of moisture, not a lot, but basically coming from the Pacific across California all the way to the East Coast. It's not a lot of moisture there. And then there's some out over here, well out offshore. It almost looked like there's pretty fast southwest to northeast flow across the United States right here. And some areas of enhanced moisture. There's some over Oklahoma, some over Illinois, Indiana, Iowa area. And notice this. You can actually see rotation here. And seems to be something dropping to the south here as well. So gives me an idea that out west there's kind of a trough of low pressure somewhere out in here. Just ballparking, looking at things just from a satellite perspective. So let's go on now and look at a surface map. Well, we talked about a front, and all of a sudden, here it is. Matches up pretty well with that area of clouds. Saw a little bit of enhanced moisture over Oklahoma. Well, here's a low. So actually, we're matching up a lot of the features we saw on satellite with real-time observations at the surface. And we were talking about maybe being a front up to the north. Well, guess what? There's kind of a front up to the north here. It looks like wind went, pretty good high up here as well. So we're matching up with some features. Now that I know where these things are, now the question becomes, okay, how is this going to change in the next 24 to 48 hours? We know weather constantly is changing. So how is it going to change? Well, let's take a look up the stairs a little bit. Let's take a look at 300 millibars. We can see how it changed here. Go back 21 hours, you can see, oh, there was a front here and here all the way down. And now the latest moved up into that area. The front has actually moved back to the north, become stationary. Well, we talked about a lot of moisture from the southwest to the northeast. Look at the flow here, southwest to northeast. Pretty strong winds along that jet. Matter of fact, probably a speed max in here coming into the Pennsylvania. Good divergence out here with very strong 125 knots, 115, 120 there. So that, there's over 100 knots here. So there's a definite speed max. So with that, we have the low here. You would think that, there's going to be some divergence, and there is, all across this area. So this area of winds are going to be propagating along this front, right, along this boundary. The front's going to stay to the south of this a little bit. So this low that's down here should be moving out to the northeast with time as this moves along. And we look at 850 millibars and we see, oh yeah, there is that low at 850, pulling up a little bit of moisture out of the Gulf of Mexico. Not a great amount. Warm air advection coming up through here, lifting. Warm air rises, so we know it's rising over the front. So that's what's causing all of that clouds. So we would expect this to propagate to the east along this with time. So based on that, I'm expecting clouds would be increasing to the east. And precipitation would probably be starting. That's all based on what we're looking at on observational data. So you're going to want the details. So when would you want? You would want to know, oh, is the rain going to start at 7 o'clock tonight? Or is it going to start at 4 a.m. in the morning? Or is it going to be snow maybe? I mean, look at this. Here is your temperatures. It's 1 degree Celsius right here. And up in here, it's below 0 Celsius. So it's below freezing at that level. We know that precipitation is probably going to start as snow aloft. So you know at least up to about 3,000 to 4,000 feet up, it's going to be snow. And if you looked at the surface, you saw it was pretty doggone cold up over Ohio, for example, or into northern parts of West Virginia. So maybe we might be looking at some snow there instead of rain. Another interesting question. So I wanted to show you what we take all of this current forecast, current information, and we look at it in numerical models. So with that in mind, look at how many different models we have. We have a global model right here, GFS, Global Forecast System. We have a global ensemble forecast. When we're talking about ensembles, we run the same model with different initial conditions and a little bit different physics to make an ensemble forecast. May not have quite the detailed resolution this model does, but it's close. And we look at that, and then we get a mean of it and the spread. The bigger the spread, the more uncertain the forecast is. So it gives you an idea that, oh, I can see this. I am a little bit uncertain on this weather pattern now. Especially the further out I get, that spread tends to get bigger. And there's something called the North American Ensemble Forecast System. That includes the Canadian model, our GFS model, which is the United States. It includes an Air Force model. It includes a Navy model. So there's a series of models that are in there, making it an ensemble forecast. Completely different than the global forecast system model. Some of them are. So again, gives you some more ideas of where things are going, how things are going to evolve. Then we get down to the more high resolution models. We have the NAM, North American Mesoscale model. And we have a high-res version of it. That high-res version looks at details. If I'm looking at a broad picture and I want to narrow down to some details, that's what I'm going to use. We have a rapid access model, a RAP model, which basically is updated in real time about every 3 to 6 hours. And we have the HRRR model. That's my favorite as far as looking at the next 12 to 18 hours of a forecast. Why? Because it has the highest resolution, fairly accurate model, and it's updated hourly. So it looks at all the new data such as coming in from the radars. Oh, maybe an airplane's flying over an area. That data comes into it. All this information comes into that model. Same information goes into the other ones, but they're only run every 6 hours. This is run every hour. So it's constantly being updated. Maybe a line of thunderstorms develops that the other model didn't know was going to even be there. This HRRR will pick up on that line, realize it has formed, and begin making a forecast of where it's going and how it's going to change. There are some other ones. The SHREF is just an ensemble forecast of high resolution. So all of these are different model forecasts. So let's look at one of these model forecasts. Let's just take a global model. And we're going to look at it over the CONUS. And I have a whole bunch of different fields. If I was at work and I was working for the Weather Service, I could create my own numerical fields from the raw data. I'm not at that. I don't have that access. But let's say I wanted to look at 850 millibars, mean sea level pressure, and precipitation. So let's just take a look at that. Oh, I can run loops of that, and I can stop and start this loop. That's kind of cool. So here's a loop coming down. And we can see right here that low we were talking about. Look at it coming out right here. Here it comes, produced precip, and develops and now moves out, intensifies off the coast. So the same low we were talking about. Let's go back and look at that a little bit. Well, there it is this morning. And we were asking whether that low was going to come out. Well, there's the precip developing out ahead of it. The model's actually indicating not a lot of precip. And it keeps bringing it out to the east. And it all depends on where the front and the jet are, so where this low goes. Right now, I live here. Most of you might live up in West Virginia, this part. Low's going right across this area. Most of the precip lifts north of the front, as we know. So there's where the rain. And here's that zero line at 850. Anywhere north of that line, some of this precip could be snow. The further north, the better chance of it. So you can see how it's wrapping in and tightening up the gradient of temperatures across it, which helps strengthen the low. As it's moving out here, it's coming out to my north, so better precip up to the north. It's even picking up some moisture now because it has, think about it, counterclockwise. It's coming in off the Gulf Stream out here, the Atlantic Ocean. More moisture is coming in. The precip will be heavier. And notice the zero line moved all the way through West Virginia now. Maybe by tomorrow afternoon, some of you all might be seeing some snow showers here on Thanksgiving. And that intensifies and moves away. So that's the first part of the forecast. Now I've gotten into front, literally through Thursday night. Notice this big high. 1038 high up here. Pretty good size. 850 temperatures. In the wintertime, I look for Arctic air to come out of northern Canada, the Arctic, and I'm looking for temperatures around minus 20 or lower coming in. Sometimes I see minus 30s and even minus 40 coming in to North Dakota. It will moderate, as we know, coming southeast. Notice minus 18 here, minus 12 here. Here's a minus 6. My house, I'm still plus 3, so it's lower. But there's definitely a cold front that's probably right through here. If I were to just take this off now and just let it start, move from here, we can watch this high come down out of Canada. And we see this big low. Doesn't seem to be, this one doesn't seem to be moving anywhere. And this low gets up here, slows down, almost like it wants to come back. Yeah, you can almost see it coming back into the other low. So there's something blocking it to the northeast there. So with that in mind, that's keeping that low there, pulling the north wind down over top of us. And high after high is coming down out of northwest Canada into the central United States. The 850 temperatures keep getting colder, which means it's going to be colder at the surface. Remember, you can do adiabatic right down on 850 and know exactly how high it could possibly get. And you just see one after the other coming in there for a while. Now they're kind of pulled out a little bit. This is next Thursday, which we're getting out to science fiction land. But there goes another one. The big high sitting over us. There's a big low coming out there. And finally another one. So this gives you an idea of how forecasts are made. We could have looked in high resolution back at this model here. And I could have showed you that, I'm more curious now maybe about tomorrow's forecast. So I could have looked then at this high resolution model. I could say, oh, I want to go U.S. North Central, maybe go Northeast. Not exactly sure where I'm looking at here. And now I want to look at radar. I want to see what radar looks like. For that same time, we can loop it all. And notice the timing. Now I'm coming in with real timing. Here's the precip, and it even shows where it's going to be snow, potentially. And notice all the precip moving out ahead of it. Hardly any at my house, maybe a few showers. Most of it stayed to the north of my area. So, great high-resolution tool that gives you an idea of what's going on. Notice all the snow that was still in the mountains, and notice the lake effect continuing. So if you lived in Erie, PA and stuff like that, you'd be getting all that lake effect. So hope you got a little bit out of this. This is really combining everything you've learned, all the observational data, and everything into a forecast, and you can actually see in real time how that forecast is being made. So let me know if you have any questions.